The research that I'm going to be sharing with you is it's not just done by me. I get a lot of the credit for it all around the world, and I get flown all around the world to speak about it, but it is a team effort. And we sort of work on that vitalistic principle that we are greater than our individual sum of our parts. So we work to our strengths in this little team. There's only 3 full-timers. One of them's a bioengineer, that's Imran Khan Niazi, standing to my right, and Kelly Holt, who's a chiropractor, PhD, standing to my left. So we're the 3 full-timers, and all the rest are either student volunteers or they are postgraduate students. And out of this little team in New Zealand, we do shitloads of research. Couldn't help that one, so sorry. We also collaborate with an awful lot of researchers from around the world, and a lot of them are not chiropractors. And we do that on purpose, because if we chiropractors were just sitting in our own little lab, producing research, publishing it in our own journal, it's worth diddly squat to you guys. You know, it has to be published in really high, reputable, decent articles. We publish most of our work in neuroscience journals because it's neuroscience research. And how many chiropractors do you know of that are neuroscientists? I know of less than 5. Are you with me? So it can't be published in chiropractic neuroscience journals because they don't exist. So we publish our work in neuroscience journals, but the problem with that is we get neurosurgeons and neuroscientists reviewing our work, having no understanding about what it is that chiropractic is. But the funny thing is, neuroscientists really get it. They get what a subluxation is within about 5 minutes, if I tell them what we're understanding based on the neuroplasticity story. If I talk about a subluxation to neuroscientists, I usually call it a central segmental motor control problem. And don't worry about that one, you know. But what it really means is the brain isn't controlling the movement pattern of a part of your spine appropriately. And then I say this causes maladaptive plastic processes within the central nervous system. And it particularly affects the prefrontal cortex. Isn't that fascinating? Usually by then, we're having a really interesting conversation and they're right with me. So I've practiced chiropractic. I've seen what you guys see in practice. I think that's one of the reasons that I've been able to do the research I've been able to do, because I've asked questions based on what I see in practice. If you've got a chiropractic scientist doing research who's never practiced, well, what do they think chiropractic is? Do you know what I mean? So I think it's really quite key that, and our whole team, we always encourage anyone that's part of our team to actually practice, to see what it is that can happen when you put your hands on these spines and you adjust subluxations. But most importantly, what I've spent the last 20 years doing is actually doing the research, actually collecting the data, analyzing the data, writing up and submitting papers to journals, and it's literally looking at what are the effects of having spinal dysfunction. How does that impact the brain and the body? And what are the effects when we adjust subluxations? That is literally what I spent the last 20 years doing. And that's the key thing. We're actually changing the brain itself, not just improving communication across a nerve route. But this neuroplasticity model is really where it's now at. I'm not trying to claim that we know everything yet. We really, really don't. But the key take-home message is we now have 20 years of research supporting this model. So that's the big deal. Yet we've got now 20 years of research showing that the way the spinal muscles, the little muscles closest to your spine and skull, the way they communicate to your brain changes the way your brain perceives what's going on in your body and your world around you. We also know that that means that the brain cannot function in an ideal way. It cannot control your body accurately for what you were trying to do right there and then. We also know, based on this 20 years of research, that when we actually go in there and adjust these subluxated areas, we again stretch those little paraspinal muscles, the little ones that cross the vertebra, that are closest to your spine and skull. Those guys we stretch, they're chocker full of stretch receptors. They again blast the brain with information. It's like rebooting the computer. The brain goes, whoa, I now know exactly what's going on at this spinal level. And the freaky frickin' thing is that this changes the way your brain perceives what's going on in your body and the world around it. We've done studies showing that the way your spine functions changes the way your brain interprets what you see and hear. I mean, isn't that freaky? It blows me away. But no, there's no possible way that a spinal nerve root can interfere with hearing, right? Harvey Lillard's story, are you with me on that, Kairos? But yeah, we've actually even shown that we can change cranial nerve function. We can change jaw strength. There are so many cool studies that support this model. The cool thing is, and the take-home message, we finally have a model, one model, at least one. I'm not saying it's everything, but one model that is biologically plausible and supported by scientific research.